Hey guys, so today I'm just going to do a video on a ton of foundation questions. So all from the foundation set. These are all from Edexcel's papers. But even if you're on AQA, OCR, anything like that, this video will still be helpful for you. So I'm just going to go through a ton of questions. There's no particular order to them. Some are going to be trickier than others, but it's just a mix of everything. So let's start. So for this one here, what have we actually got? Well, we've actually got here a question involving money, right? It's one of these sort of questions. We've got 3 kilograms of meat costs £54. Nina buys 2 kilograms of the meat. Work out how much Nina pays. Well, if 3 kilograms of meat costs £54, can we work out what 1 kilogram costs? So 3 kg is £54. So what's 1 kilogram? Well, 1 kilogram would be dividing this by 3. So 54 divided by 3. Well, what's that going to give me? It's got to be bigger than 15, because 15 times 3 is going to be 45. It's going to be less than 20, because 3 times 20 is 60. So it's going to be somewhere in the middle. If I do 18, so it's going to be 18, 36, 54. Perfect. So a kilogram, 1 kg, is £18. So what does that mean? That 2 kilograms costs? Well, 2 kilograms, which times that by 2, so therefore 2 kilograms is £36. Boom, 2 marks done, nice and easy. Question 9 over here. We've got the centre of this circle, marked with a cross here, and we're given this line going to it from the circumference on the outside. So we have to just do, for 1 mark, the mathematical name of this straight line. So remember guys, this line here is the radius. Be careful not to get it confused with the diameter. The diameter goes all the way across. If it goes only from the halfway point of the circle, the centre, to just a point on the circumference, it's just the radius. So A is the radius. And then for part B, we've got this line here, the name of this straight line that's touching the circle. So this, again, it's just 1 mark, but this is what we call the tangent to a circle. So you can just write this as the tangent. Another 2 marks in the bag. So here we're looking at column vectors for the first question, and in the second question we're looking at equations of graphs. So for question 26, you have to work out 2a plus b as a column vector. So they give you the column vector here. So you've just got to work out what 2a plus b is. Well, a is equal to 5, 2. So what's 2 lots of a? Well, 2a, that's equal to 2 lots of this vector here, right? 5, 2. Well, b is just this. So what we're going to work out is this, which is 10, 4. Remember, for vectors, guys, and column vectors like this, you just multiply each term individually. So 2 times 5 gives me my 10, 2 times 2 gives me my 4. That's 2a now, that vector there. Well, plus b, so 10, 4. I know my vectors are a bit messy. 10, 4 plus b, which is plus minus 1, 7. What's that going to give me? Well, 10 plus minus 1. So be careful here. It's a very common mistake. We're going to actually subtract the 1. Be careful that you don't do anything crazy here. So 10 plus minus 1 is just the same as 10 minus 1. So that gives me 9. 4 plus 7 gives me 11. So that's my column vector there, like that. So obviously your top one would be 9, bottom one 11. Question 13. We have 6 straight line graphs. You have to match the equation in the table to the correct graph. So the first equation, y equals 2. We have to figure out which one this is. Now, straight away, you should know this is just going to be either a horizontal or vertical line. It's going to look either like this one here, graph B, or it's going to look like this one, graph D. Now, you've got to decide which one it is. So at the end of the day, it's a 50-50, but only one of them's correct. So how do we know which one? Well, it can't be graph B, and the reason is because if I pick this point here, this is x is 2, but y is 0. But the graph y equals 2 means every point on that line, y is equal to 2. So if I did it on this one, for example here, this is x is 2, y is 2. X is minus 2, y is 2. So straight away, y equals 2. That is the graph D. Graph D. y is equal to x, well, straight away you should know sort of what y equals x looks like. What it means is that every x value is the same as the y value. So if x is 0, y is 0. So it's going to either be this one or this one. When x is for example 2, y must be 2. So this looks pretty good. And when x is minus 2, y is also minus 2. Perfect. It can't be this one because when x is 2, y is minus 2. So that's not correct. And when x is minus 2, y is 2. So this is not y equals x. So be careful for that. So y equals x is the graph f. And then finally, we have the graph x plus y is equal to 2. So how do we know what this one is? Well, it might be in a form that you don't quite recognise here. Remember, we always like straight lines in the form y equals mx plus c. So we've got to get it in that form. So that's going to give me y equals 2 minus x. So straight away, you're going to have to do a bit of thinking about this one. We have a gradient here of minus 1 minus x. And this intersects the y-axis at 2. If x is 0, I get y is equal to 2. So it's going to have to cut through 2. So it could be that one possibly. It could possibly be that one, but we've already said that's y equals 2, so it's not that. So it's either E or A. Well, how do we decide which one it is? Well, remember, this is a negative gradient, so my graph has to go down that way. It can't go up. That's a positive gradient. So that means this also has to be graph A. So this one is A. And there you go. That's another 2 marks in the back. Moving on again, question 11, we've got a bit of algebra, and then question 27 over here, we're looking at a bit on vectors. So let's do this one first. For part A, you've got x plus x plus x is equal to 51. So what's x plus x plus x? Well, x plus x gives me 2x plus another x, that gives me 3x. So after simplifying that expression there on the left hand side, this is equal to 51 still. So how do I work out an equation like this? Well, to get the x on its own, we need x on its own at any point when solving an equation. We're going to divide 3 by 3, so that gives me x. 51 divided by 3, that's going to give me 17. 17, 34, 51. Perfect. For 1 mark, x is 17. This one, nice and easy again. Y over 4 is equal to 3. So this is a quarter of y. Well, if a quarter of y is 3, to get rid of this, so we're dividing, so we do the opposite. We times by 4. So if we times by 4, that just gives me y. Y over 4 times by 4 is just y. Remember, because it's an equation, whatever you do to one side, do it to the other as well. So 3 times 4, 12. And there we go. And then part C, 2f plus 7 is equal to 18. So remember, we've got to get rid of this 7 first before we do anything. So because this is plus 7, we do the opposite, we subtract 7. So 2f, oops, that's not very good, 2f is equal to 18 minus 7, so that's going to be 11. And then f is just going to be a fraction here. So f is going to be 11 divided by 2. Remember, because this is 2 times f, we do the opposite, so we divide. So f is 11 divided by 2, which is the same as 5.5. Both answers are acceptable, whichever you're happy with. So that's 3 marks again. Question 27 over here. We've got a little bit on vectors. So we've got to find in terms of b, the vector db. So this should give you a clue that the answer is just going to be b. That's all that means. Well, the vector d to b, so we're going to go from d here all the way up to b. Well, because it's a parallelogram, what this means is this length here, b, it's also the same here. From d to o is the same as o to b. So this line here is also a b. So from here to here, that's 1b. From here to here, 2b. So part A is 2b. Part B, we have to find in terms of A and B the vector AB. So we're going from A here to B. Well, the vector A here is travelling in this direction. So we want to go from A to O, we're going to have to go opposite. So if we're going opposite plus A, it's minus A. So that's minus A. So that takes me from A to O, but we've got to get from O to B still. So that's going to be plus B. So minus A plus B for that part there. That's a B. And then part C, finally, we have to find the vector AD. So we're going from A to D. Well, if we're going from A to O, that's going to be minus A, just like we did here. So that's minus A. And then if we're going from O to D, because we need to get AD, that's going to be minus B. Remember, B travels in that direction, so it's going to be minus B. So minus A, minus B. And there we go. So doing some more foundation questions. Question 1 here. we have to change 365 centimetres into metres. So the key to doing this is remembering that 1 metre is 100 centimetres. So if we have 365 centimetres, well, that's going to be 3 metres, and then we've got to add on the 65 as well. So what that's actually going to be is 3.65 metres. And then for part B, we have to change 2.7 kilograms into grams. So how do we do that? Well, we've got to remember 1,000 grams is 1 kilogram. So 2.7, well, that's going to be 2,000 grams plus an extra 700. So 2,700. Nice and easy. Question 23 over here. We have to express or write 36 as the product of its prime factors. So remember, the easiest way to do this is to do your prime factorization tree. So 36. So that's going to give me 2 and 18. And then circle the prime numbers as you go down. So 2 is prime, so we're going to circle that. 18 we can split as 2 and 9. Again, 2 is prime, circle that. 9 we can split as 3 and 3. Both of them are prime, and there we go, that's our prime factorization. So you can write it as 2 times 2 times 3 times 3, or you can write, and this is a nice way to write it, 2 squared times 3 squared. So what that gives you is 4, that gives you 9, 4 times 9 gives you 36, and you know you're correct with that. So for this question, question 19, we've got a bit of algebra, bit of rules on indices, and then for this one over here, we're expanding 2 brackets. So let's do this one first, question 19. For part A, you have to factorise y squared plus 27y. So remember, when we're factorising, that means we're going to put it into brackets. So it's the opposite of expanding it. So for this one here, part A, we have to look at both terms in this expression. So we've got a y squared here, and we've got a 27y here. So what's the biggest thing in both of these, or what belongs to both? Well, there's a y squared here, 27y here. So notice the only thing we can actually pull out is a y, like that. Then we're going to have a 1 bracket here. Well, what do I get when I times y by something to give me y squared? Well, that clearly has to be a y there. Y times y gives me y squared. We know that's correct. Then I've got to think, when I do y times something, I get 27y. So what's that number? Well, it's just going to be 27. Because when I do y times 27, I get 27y. And that's a good way to check your answer. We know that's correct without even looking at a mark scheme. Part B. A little bit of rules on your indices now. When you have a power here, and then you've got it all raised to another power, remember you multiply the indices. So this is just going to be t to the power of 6. And then here, again, it's just another rule of your indices. When we've got powers divided by this, like the same base, so it's w to the 9 divided by w to the 4, we can subtract the powers. This is the subtraction law. So w to the 9 divided by w to the 4, that's just going to give me w to the 9 minus 4. So 9 minus 4 gives me 5. And there we go. We know them are both correct as well. Question 22 over here. We have to expand and simplify this expression. So remember, when we're expanding and simplifying, we've got to use FOIL. This is a really good way to help you remember. So you do the first 2 terms, the outside terms, the 2 inside terms, and then the last 2 terms. So expanding this, m times m, because these are my first 2, that's going to give me m squared. Outside, so m times 3, that gives me plus 3m. The inside, so this is this one and this one, so 7 times m gives me plus 7m. 7 times 3 plus 21. So let's simplify that. That means just collect like terms where possible. So there's no other m squared, so that's just going to be m squared. 3m plus 7m plus 10m. And then there's just a plus 21 at the end, and there we go. We have it fully simplified, and that's it expanded. So that's your extra 2 marks there. So we got a bit more algebra here. Question 11. Part A, we've got b plus b plus b plus b. So what does this actually simplify to? Well, you've got to remember, this is not b to the power of 4. This is b plus b plus b plus b, which is 4 lots of b. That's all that will simplify to. Part B, an minus 3n. So imagine you've got the number 8 on the number line and you take 3 lots of it off. So that's 7, 6, 5. So I have 5n. That's all I have left. The way to think about it is if you had 8 chocolate bars and someone takes 3 chocolate bars off you, how many chocolate bars have you got left? I've just got 5 chocolate bars left. Part C. 3 times C times D. What does that simplify to? Well, remember, when we're ever simplifying something like this, where it's got letters and numbers multiplying, all you do is just write it as this. So this would be, for example, 3 times C times D. We just write it with the letters. So that's 3 times C, the letter C, times the letter D, which is that's all you can simplify it as. And then part D, we have to simplify 3x plus 7y plus 2x minus y. So do one letter at a time here. So let's start with the x's. I've got 3x and I've got a 2x. So when I've got 3x plus 2x, how many x's have I got in total? I've got 5x. Then go on to the y's. So we've dealt with the x's. Let's move on to the y's. I've got 7y here and I've got a minus y here. So you've got 7 chocolate bars. Someone takes one off you. How many chocolate bars have we got? We've got 6y, or 6 chocolate bars left over. And that's part D done as well. Question 10 here. There's 210 counters in a bag. 30% of these counters are red. We have to work out the number of red counters in the bag. So you've got to be okay working out percentages. The nice way to do this is work out 10% and then scale it up to the number that we need. Well, if the starting number is 210, 10%, we're just going to divide this number by 10. So 10% in our example is going to be 21. So that's 10%. Well, then if we need 30%, how do we get that? Well, we're just going to do 21 times 3 as well, because we times that by 3. So we're going to do the same there. So we times that by 3. 21 times by 3, that's going to give me 63. So the number of red counters in this bag is 63. So we've got a bit on fractions here and then a little bit on arithmetic sequences. So let's do the fractions first. Hopefully you like these fraction questions. Think of fractions as 3 marks when they come up. They can never really ask you anything too bad with fractions. You've just got to be okay with the rules. So multiplication of fractions, remember, we do the top number times by the top number, or the numerator times the numerator. So 2 times 3 gives me 6. That's my numerator. 5 times 8 gives me 40. Can I simplify this? Because this gives you a hint as well. Give your answer in its simplest form. Of course we can. 6 divided by 40. Well, I can simplify that as 3 over 20. Dividing top and bottom by 2. And we can't simplify that any further. Because 3 is prime. We can't do anything more with that. So 3 over 20. Perfect. There we go. Part B. We've got to work out 3 over 8 plus 1 over 4. So remember, the golden rule for adding and subtracting fractions, we need a common denominator. We can't add this until they've both got a denominator of 8. And I can get that just simply by timing this fraction here by 8. So what I get is 3 over 8. The left fraction won't change. Plus, so if you times both top and bottom by 2, that's going to give me 2 over 8. So that's my right hand fraction here, times in 1 by 2, times in 4 by 2. I get 2 over 8. Then, remember, you just add the numerators only. So 3 plus 2 gives me 5. Your denominator stays the same. 5 over 8. There we go. Here, we've got an arithmetic sequence. We've got 5, we're going to 9, we're going to 13, we're going to 17. What is the next term in this sequence? Well, you've got to look at what it's going up by. And arithmetic means it'll always go up by the same amount. So to get from 5 to 9, we're going to add 4. To get from 9 to 13, we add 4. And let's keep going. So 13, 17, we add 4. If we add 4, what's the next term? So that's just going to give me 17 plus 4, 21. Part B. We have to write in an expression in terms of n for the nth term. So the nth term means a formula that lets you work out any term in the sequence. So how do you obtain the nth term? Well, there's a couple of ways of doing it. The easiest way is the difference between each term. So in this case, 4, that's your n. So this starts as 4n. That's the nth part of the sequence. And you're always going to usually have a constant that's added. Well, for this one, what you do is you take the difference off your first term. So 5 minus 4 gives me 1. So my sequence is 4n plus 1. And you can double check your answers. If you put 1 into here, so the first term in the sequence, we should get 5. So 4 times 1 is 4, plus 1 gives me 5. Let's put 3 in here. We should get 13. 4 times 3 is 12, plus 1, we get 13. Perfect. We know it's working. So, another question, we're looking at indices. So this is 7 to the power of 0. So you've got to remember this. Let's just change my colour in my pen. So anything to the power of 0 is always 1. So 7 to the 0 is 1. 5 to the minus 1. How do you work out the value of that? Well, 5 to the minus 1. The way you should do this is think of this as a fraction, right? So this is 5 to the minus 1 divided by 1. So I'm going to flip it. So that gives me 1 over 5 to the 1. When you flip it, you make the power positive. So for example, if I were doing 4 to the minus 2, that becomes 1 over 4 squared, like that. So 1 over 16. Same here, it's just 1 over 5. And then or triple I, we have to write down the value of 9 to the power of a half. Well, how do we do this? The easiest way to do it, or remember, is that the power of a half is the same as the square root. So what's the square root of 9? Well, that's just going to give me 3. That's a 3, believe it or not. Just get rid of that. So square root of 9 gives me 3. And then 13a, we have to write down the equation of a straight line that is parallel to y equals 5x plus 6. Well, how do we do that? Well, remember, if a line is parallel, it just means it always has the same gradient to the given line. So our gradient here is 5. This is the mx bit here. So m is 5. So we just need to write down any line that's parallel to that. Well, you can be as creative as you want. There's technically infinite answers as well. So I'm going to write y equals 5x plus 3. But you could put anything as long as it's got a 5x there, and it's y equals. Just make sure it's 5x here. You could put 1, 2, a million if you really want. Just make sure it's 5x. So I hope these questions have been helpful, guys. Best luck for the Tuesday exam, for the paper 1. I'm sure you'll all do great. Be sure to subscribe. Check out any other videos if you need help with any other topics. There's plenty on my channel. And best of luck.